Okay, so we are on Unit 7, and the topic is configuration management. So in this study unit, configuring a software is discussed in detail. Configuration management consists of the following activities. So it's all about version control, system building, change management, and release management. So we'll sort of break down each of these during the lecture. The previously mentioned activities are discussed in detail. During version control, the essential functionality should be discussed in detail, and there is a need to have a thorough understanding of how the version control system can be realized and centralized and distributed systems. Okay, so we will cover the following learning outcomes. Demonstrate a detailed understanding of all the essential functionality for a version control system and how they can be applied in centralized and distributed systems. Have a thorough understanding of some of the challenges of system building and analyze the benefits of continuous integration during system building. Demonstrate an ability to analyze and evaluate the importance of change management, as well as applying the essential activities of the change management process. And then lastly, demonstrate a detailed understanding of release management and be able to evaluate how it is different from version management. Okay, so when we talk about configuration management, it's more of a generic term to defining our processes for managing change, releases, versions, and system builds. So configuration is a generic term, and we tend to look at configuration as a way of managing how a software evolves. Okay, because most of the activities under configuration management fall after the deployment phase of the SDLC. So if we've deployed the software, now we're managing how it's in terms of all the changes. How do we keep track of all the changes? So just in summary, that's what the configuration management is all about. So we say software configuration management is a set of activities that have been developed to manage change throughout the life cycle of computer software. Software configuration management can be viewed as a software quality assurance activity that is applied throughout the software process. So it's more of a quality assurance thing to ensure that everybody who's part of the development team is aware of the latest changes. Okay, so keeping track of them, documenting the status of changes, and so forth. And also, since we're working on the project as the project team, there needs to be a formalized structure or a process for implementing change. We can't just, the one person wakes up the next morning and decides, I want to change this component. There has to be a formalized process for even initiating the change. Okay, so you bring about the change, you have a good idea that you want implemented, but we need a formal process as part of quality and assurance. We need a formal process for approving that change for it to be implemented. That's why we say it's a quality and assurance activity. Okay, because then people will start chopping and changing things by themselves, and then there's going to be a disconnect between the team members, and that compromises the structure of the software. So change management continued. So we say software systems are subject to continual change requests. Where do the change requests come from? They can come from the users, okay, which means this would have been through a release. So we release the software to the users, and maybe it's the first version or the demo version, and they're able to give feedback on what they like and what they don't like about the software. So change can come from the users, okay? Change can also come from the developers themselves, okay? And I said people coming in with new ideas, so they'll bring about change. Market forces. what happens in the market that we are operating in? What is the new thing? What is the new thing that everybody is using? If it's really something that is efficient, then we also may want to use it. So it's going to force us to change our systems or change systems somewhere. So market forces, whatever is happening in the market, new technology being introduced, that's going to force us to change. Okay, so these are the three ways in which change comes about. So change management is concerned with keeping track of these changes and ensuring that they are implemented in the most cost-effective way. So new versions of software systems are created as they change. And we've seen this more often than what's happened in the previous slide, is they say users, developers, and market forces. But what about change that is brought about due to new platforms being released or new versions of operating systems being released? So we have Windows 10 coming out. So you're going to need to make configuration, to make changes so that your software is able to adapt to Windows 10. Okay. So more often you'll find that software will evolve because there's a new platform or a new operating system, version of operating system being released. Also, it will evolve because of functionality. We may just need to add additional functionality, okay? And then tailored for particular user requirements. So maybe we are customizing our solution for specific users. So these are some of the common reasons why software will evolve. So configuration management is concerned with managing evolving software systems. So systems change is a team activity. Configuration management aims to control the costs and effort involved in making these changes to the software system and associated documentation. So we're looking at how can we minimize the costs of changing code and changing documentation. Because when something is not done in a structured process or a structured manner and everything is informal, then people end up going in circles. And that's going to cost you more because, and we've said this before, if you're looking at cost and effort is how much the people that are working on the project, how much effort they put in, and you pay those people per hour. So the amount of effort they put in ultimately determines the cost of making the change. So we need to, if we have a structured process in place, we make sure that everybody's on the same page and we implement the change once and not multiple times, and hence minimizing the cost of implementing the change. So again, we say that configuration management is the umbrella term that speaks to how change is managed, how versions of a system are managed, how systems builds are done, and how releases are managed. So in order to implement change management, you say that changes of a system may be due to proposal change, faults or errors on new hardware or software being released, okay? So this is somewhat linked to what we said previously in the other slides, that your documentation, your proposals, there may be additional requirements. We know with agile software developments that things are constantly being added to the scope. So proposal will change here and there, and it depends also on how late in the SDLC did this change come about, which will influence whether we actually initiate our change management processes or not. Because sometimes change comes about so early in the project that we don't need to do the whole formal process. We can just simply change the documentation. Nothing has been built yet. So we can just simply change the documentation and that's it. But then when it becomes a problem when we already have something that's already been deployed and somebody wants to implement change, which means now the code has to change and also the documentation has to change. A process to decide if changes should be included in a system, software to keep track of suggested changes and their requirements on the status, and software support for managing changing systems configurations and building new systems. Okay, so it's good that you make this the whole process of change management more software based more than anything. There will be forms that people who want to implement change have to fill out, but it's not going to be physical printed out forms. It's going to be something on a some sort of software, and then the change goes through the different stakeholders involved for approval purposes. So there will be definitely some sort of software involved where the change is going to be put in the pending state once it's initiated, waiting for approval from external or internal other stakeholders. Okay, so this change request form. So a change request form is then used and must be filled out by the person who wants to initiate the change. This is part of our record keeping and our documentation. The definition of a change request form is part of configuration management planning process. This form records the change proposed, the request of the change, the reason why change was suggested, and the urgency of the change from the request of the change. It also records change evaluation, impact analysis, change cost, and recommendations. Okay, so if we're looking at the change request form, I think it would more apply to the project team more than anything. So you wouldn't require your users to fill out a change request form, okay? Because the users just give you feedback, they criticize your solution, and then you as a development team need to then look at the feedback from the users and then go through the formalized change management processes. Okay, so the change request form is not something that's given to the end users. It's more of something that is done by the project team to initiate change in the project. Okay, based on a number of factors. Users' feedback is could be one of the factors, and changes to market forces, new technology being released. Okay, and then the project team says, look, we need to implement change. Okay, so if you look in the slide that follows, it's actually just a sample of how this change request form would look like and all of its components, okay? As highlighted in the previous slide, okay, so it has the name of the project, the number of the project, who requested the change. You can see it's requested by Somerville, the date which the change was requested, the actual requested changes, change requester, components affected, sorry, change analyzer, which is Dean, components affected, what kind of components will be affected, when was the analysis done, and so forth, and change priority, is this low priority, is it high priority? We may need to prioritize the high priority changes, okay, because they have a rollover effect on the entire software. The low priority changes are subject to approval as well by the Q&A team, by the assigned board for reviewing the change. Sometimes they may feel like the change is unnecessary, and so the change is rejected, okay? It's all about weighing out the cost. How much is it going to cost us to implement this change, and is it worth it, okay? So this is how a typical change request form would look like. So change approval. Changes should be reviewed by an external group who decide whether or not they are cost effective from a strategic and organizational viewpoint rather than a technical viewpoint. So we don't look at it as a technical decision to say, oh, when a user clicks on this particular feature of the software, then it's going to crash. We don't look at it from that point of view. We're looking at it from a cost effective point of view. Is this feature really a core feature in the software, and is it worth fixing? The money that we're going to take out to fix it, are we going to get it back? Okay, so this change approval team should be independent of project responsible for the system. The group is sometimes called a change control board. Okay, so the change control board is the one that actually reviews all the changes. So once the team fills out a change request form, it is subject to approval, and they need to prioritize it to say, look, this is high priority, so you really need to consider it for us to implement it. Otherwise, it's going to cause the whole system to fail. So they make an informed decision based on the information given to them in the change request form. And they say that the change control board may include representatives from the client and the contractor staff. Okay, so we say to establish this independent team that reviews change, we need a representative from the client organization that you're doing the software for. We also need a representative from our project team so that we get views from different sides. Okay, so each side is able to state their case. Maybe the clients will say, we really don't have that much money left to work with. And then the contractor staff may say, but you really need to implement this change because it is high priority and so forth. So it's very important for transparency purposes that the change control board is independent and it consists of people from the client and from the contractor. Change tracking tools. A major problem in change management is tracking the change status. So change tracking tools keep track of the status of each change request and automatically ensure that change requests are sent to the right people at the right time. Integrated with email systems, allowing electronic change request distribution. Okay, so this goes back to what I was saying earlier, that the change request form is not much of a manual printed out thing, but it's more of a digital thing. And it could be done, it could be a form on a system that it needs to be filled out by the person who wants to request the change. And then once they've completed all the required components of that form, then an email is sent to the change request board or a particular member in the change request board for evaluation purposes. Okay, so we can do this in an electronic manner, and it's very good when you do it in an electronic manner because tracking the status, whether it is rejected or approved, becomes more of an organized and structured thing. Okay, so documenting change history. So this is a record of changes applied to a document or a code component. When we are programming, we are able to put code or comments on our code. That is another way of documenting change. So the change comes in, the change is approved. Now, as a project team, we need a way of keeping track that a particular component has changed since the last version. Okay, so we apply the change to the documentation, we update the documentation, but you also apply the changes to the code or the components. Okay, so usually we put in code comments in our code to say, this has changed, this is the reason why it's changed, so this is the new structure of the code and so forth. So code comments are very important and they form part of us documenting the history or changes while we're implementing this, or while we're implementing these changes. So now we're going to talk about version management. So what is a version? Okay, so a version is something that's still localized on our computer. It's basically a build that's still localized on our computer. It has not been deployed for use, okay, to the general public. So we can have multiple versions. And as the changes come about, then it leads to a new version. Okay, so we have a stable version, but it's not released to the public yet. And then somebody or a group of people wants to come and implement changes. So now we have to have a new version. So a new version is something that developers, or versions of a system is something that developers have locally on their system. And that version is usually assigned a version ID. Okay, so version management refers to the process of keeping track of different versions of a system and ensuring that changes made by different developers do not interfere with each other. It is crucial to note that version management is the process of managing code lines and baselines. Okay, so code lines involve earlier source code that we've already written, and we are concerned with keeping track of those earlier versions of the code because we may need to use it in the new version. Okay, so usually, in actual fact, usually when you're creating a new version of a system, you are using source code from an earlier version, and you're keeping track, or you're making improvements or changes. So we can look at version management as keeping track of code lines and baselines. So what are baselines then? A baseline is a definition of a specific system that includes a specification of the libraries used, configuration files. It also allows to define what components are included in a version of a particular system. Okay, so code lines is the code we built originally in the previous versions of the software, or in the previous versions of the actual software that you're working on. And then a baseline is more of what kind of external code, what kind of external libraries, what kind of configuration files did we use? Okay, so baseline is more of external things, also documentation, not really pertaining to the code that we wrote originally. So we need, in terms of version, we need to keep track of all of that. So we have version control systems that automate this process of version control for us. And sometimes we use the term repository to refer to these. You may have heard of repositories such as Git, where the developers put a project online, the solution, and everyone who's part of the project team has access to the latest version of that solution. Okay, for the fact that we're putting it in one centralized location, and whenever someone changes something, they deploy the changes to that central location, ensures that we have a unified system for tracking versions of our software. So what are some of the capabilities of version control systems? Version and release identification. So you don't assign IDs to the different versions. It is tracked by the version control systems. So it's gonna keep track of a incrementing number like version 1.0, version 1.1, version 1.2, and so forth. So it assigns IDs to each of the versions and the releases of the software. Change history recording, keeping track of component changes, okay? So as much as it can keep track of the versions, but also additional components that may have been changed by the developers. It enables independent development. Developers can work in private workspaces or master repository, okay? And I'll show you what they mean by independent development in the next slide. Project support, okay? Through sharing of components. Everyone has access to the components. They're stored in a localized repository, so it supports the project, okay? It supports sharing of components. And of course, storage management, just to have a virtual kind of location of storing these components or versions of software ensures also that there's proper backups in the event that a particular developer, maybe their laptop gets stolen or their laptop crashes. So we have a duplicated version of the system and its components somewhere on a remote site, okay? So there are these two types of version control systems. We can either have them centralized or we can have them distributed. Okay, so what is the difference? In a centralized version control system, it means that developer using system A and developer using system B would have to sort of wait for each other to work on a particular component because they're all accessing it from a centralized location. Okay, so once component A is done with the components, then they upload it back, they update, Okay, they update the changes, and then now system B, developer working on system B, can now download a copy of that component or version of a system and implement their changes. Okay, so it's still a repository, but it's very much centralized, so concurrency has to be managed effectively. And with a distributed version control system, as much as there is a centralized repository, but each of the developers can duplicate. Okay, so they can duplicate the centralized repository on their own local systems. This ensures that they're able to work independently. Unlike in the centralized setup, they have to wait for each other. The changes of system A, okay, influence when system B can start working on the component. But in distributed approach, there's simultaneous access because each of us have a localized copy of the repository. So you can just sort of implement the changes and then effect the changes. Once we are done, we update or we push the changes back to the centralized repository. I would say one thing, I like to compare these two also, that with the centralized approach, I wouldn't say it's all that bad, okay? Because if you think about it, it really ensures that there is a consistent view, okay? There's only one copy of this version, only one copy of the changes of the system because they're taking turns to make the changes. Distributed, it's good because we can work independently, but at the same time, I feel like there is a possibility of one system cloning an outdated version of a component, okay? Then you'll find that system B is cloning an outdated version of the component, and then system A is now pushing a more updated version of the component, but system B already downloaded the outdated version. So as much as there's independent implementation and distributed version control systems, but it's not perfect. So then what would be the difference between a release and a version? It means that a release is basically a version of the system that we have deployed for the end users to use. So for as long as it's still on your local computer as a developer, you cannot categorize it as a release. So releases must be incorporated changes forced on the system by errors discovered by users and by hardware changes. They must also incorporate new system functionality. Release planning is concerned with when to issue a system version as a release. So when we reach a phase where we are satisfied with the version, all the developers are satisfied, then we can deploy it. And it's good that we assign different IDs to versions and different IDs to releases. So it doesn't mean just because you ended up at version 2.0 while you are developing, now your release must be given an ID 2.0. No, it's the first release released to the public. So you give it its new unique ID, version 1.1 or release 1.0. So system releases, not just a set of executable programs. So another thing to consider about a release, in contrast to a version, is that a release is not just executable programs. So it's not just the code. It consists of a lot of other things. Okay, these include configuration files defining how the release is configured for a particular installation. So when you talk about configuration files, yeah, we're talking about documentation. How is the system documented? Okay, so if you're going to be giving something to end users, there needs to be some sort of documentation speaking to how it should be installed, what are the prerequisites, and so forth. Then also, a release can also contain data files. Okay, so data files are the files that are required, okay, where this software stores its data. An installation program or shell script to install the software on target hardware, electronic and paper documentation, packaging, and associated publicity. Systems are now normally released on optical discs or DVDs as downloadable installation files from the web. I think the CD and DVD method it's still valid when you're buying a software from a store, but nowadays you just buy the license and you can download the software from the developer's website. That's the new way of doing things. But the important thing to note is that a release is a more of a packaged thing. It comes with packaging. You buy the software off the shelf. It's going to be on a disk. It's packaged. It has documentation about how to install it. It has documentation about which targeted hardware, what hardware specifications you must have, and the operating system version and so forth. So those are the main differentiating factors between a release and a version. Okay, so for us to go from a version to a release, we really need to go through the process of system building. Okay, building, in other terms, compiling. Whenever you are debugging or whenever you're ready to deploy, the system must be built. If the system is not built successfully, it's not going to run. It means there is a problem somewhere. So the process of compiling and linking software components into an executable system. Different systems are built from different combinations of components. This process is nowadays supported by automated tools that are driven by build scripts. These may be separate tools or part of the programming language environment. And if you worked on Java-based systems, there are a lot of build scripts, and these build scripts are in charge of making sure that all the different components of the software are linked together and they are all available the time that the software is being compiled. If they are not available, then it's either they're going to be downloaded. If they can't be downloaded from a remote location, then the software is not going to build or compile. Do the build, so some of the problems that we experience with system building, do the build instructions include all the required components? When there are many hundreds of components making up a system, it is easy to miss out or miss one out. This should normally be detected by the linker. So the build scripts are in charge of linking up these different components, and they're going to give you feedback if they can't find if there's a missing component. Okay, is the appropriate component version specified? A more significant problem, a system built with the wrong version may work initially but fail after delivery. Okay, so are you using the latest updated version of a particular component? And that will be identified during system building. Okay, if it's not, then it's going to force you to update that particular component. Okay, and it's also going to look at which operating system version are you targeting, are you trying to deploy to, because it may work locally on your computer because you're running Windows 10, but then you're saying that in your software project that you're targeting Windows 10, sorry, so let's say you're using Windows 7 and everything works perfectly there. But once you deliver it out there in the market, it starts to fail because you're using an outdated version of a particular component, which is not optimized for Windows 8, Windows 10 and Windows 11 and so forth. Okay, so those are some of the things that are going to be detected. Are all the data files available? The build should not rely on a standard data files. Standards vary from place to place. Okay, so again, based on the framework that you are targeting, Windows, whatever platform you are targeting, the standards for creating data files will be different. So in terms of you building the software, you need to make sure that you have the correct data files for the platform that you are building for. And lastly, are data files references within the components correct? The issue of embedding absolute names in code is almost always causes problems as naming conventions differ from place to place. And what this means is absolute and relative paths. Okay, when you're talking about an absolute path, you're referencing a component using its absolute path and its absolute name, it means you're actually defining an HTTP address, which is hosted somewhere else on a different server. So if that remote server decides to change the folder or change the name of the component, it means then it breaks your entire system as well, because you are making reference to that particular absolute path. But if you're talking about relative referencing, it means that we have these data files or these components within our local project structure, which means it's not much of a problem to us because we can define a relative path, and with the relative path, it will not break because we keep our naming conventions consistent. Is the system being built for the right platform? Sometimes you must build for specific OS version or hardware configuration, which we already specified. And lastly, is the right version of the compiler and other software tools specified? So usually compilers come built into the IDE, so you don't really have to worry about that. As long as you have the updated version of the IDE, then everything will be able to compile properly, for as long as the earlier factors that we just spoke about are met. So different compiler versions may actually generate different code, and the compiled component will exhibit different behavior. Okay, so then just to summarize what we talked about in this study unit, so change management is concerned with all the activities around proposing, evaluating, and implementing changes to a software system. Change control involves assessing the technical and economical viability of change proposals. And we did say that most of the time, the change control board would really factor in the economic side of it, because already money has been spent building this software. So if you really got it wrong by a long mile, then it's going to cost them a lot of money still. So you may be working on limited resources, so the economic factor is taken into consideration, but also looking at the priority of the technical, how technical is this change? So configuration management is also the process of managing the evolving software product. And then lastly, change management tools may be standalone tools or may be integrated systems, which integrate support for change control, version management, system building, and change management. So these change control tools may be standalone, or you find that all of these features may be integrated into some sort of IDE. I know Visual Studio is very powerful, but we don't normally use it to its full capacity. It actually does incorporate all of what we talked about now. Not only do we code on it, but there is mechanisms for you to keep track, implement a foundation server, which all the changes to the software by the different developers in our team will be implemented in a centralized location and so forth, and support for change control, implementing change forms, change requests, notifying the project team of a particular or the change control board about proposed changes and so forth. Okay, so that's unit 7, and we covered configuration management. Okay, so I'll just provide you guys with the opportunity to ask questions if there are any questions regarding unit 7.